With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, there is a circuit which is given below. Now initially the switch S is in position 1 for 1.5 second. That means at this position. Then the switch is changed to position 2. Now we have changed this to this position. Now after a time t measured from the changeover of the switch, the voltage across 5 kilo ohm resistor is found to be 1.266 volt. That means across this we are finding the potential difference to be equals to 1.226. We need to find what is the time at which the voltage, this potential difference across the 5 ohm would be 1.226. Okay. Now first of all we solve for this situation. So we need to check whether our capacitor would be fully charged or not. Okay. First of all we will be checking this situation. So in the first part, when we say that one is closed. Okay, when we have closed this part. Okay, so this would not be in the in our circuit, so the current would be going here, or we can say that charge would be flowing in this way. So in this situation we can say that our time constant tau, this would be equals to RC. What is the value of R for this part? It would be equals to 10 kilo ohm. We say that it would be 10 into 10 raised to the power 3. And what is the capacitance value? It is 22 into 10 raised to the power minus 6. Now if we check this value, our time constant for the first part, we can say that tau 1, this would turn out to be 0.22 second. Okay, now for how much time this switch is opened? It is 1.5 second. That means it would be basically, if you just take the ratio 1.55 divided by 0.22, so it would turn out to be 6.8 times. Now the time constant is the time after which we will be having the charge would reach to be 63%, okay, of the maximum value. So we can sufficiently assume that our this capacitor is fully charged for this situation. Why? Because if we just take this ratio, it would turn out to be 6. Now if this ratio turns out to be 5, so we can safely assume that our capacitor would be fully charged. Now here the ratio is coming out to be 6, which is greater than 5. So we can say that capacitor is fully charged. Okay, capacitor is fully charged. Now if the capacitor is fully charged, so there won't be any current in this circuit. Okay, and the potential which would be across the capacitor, so the total potential would be dropped across the capacitor. Why? Because there won't be any current. Okay, so there would be no potential drop across this resistor. So it would be equals to V0, or the potential drop across the capacitor. It would be equals to 10 volts. And what would be the corresponding charge? If we need to find charge, we can find by multiplying this value at the steady state situation, by multiplying this voltage with the this capacitance value. Okay, now what we need to find? We need to find what is the time after which the potential difference in this part is equals to 1.226. That means if we just, now we are closing, S2 is closed. Now S2 is closed. Now when X2 would be closed, that means this is closed. Basically the current would be going in this direction, or we can say that it would be basically the direction of the charge, or charge would be flowing in this way. So that means this and this both would be in series. So we can say that our R equivalent would be equals to 10 plus 5, that means 15 kilo ohm. This would be our R equivalent. Now if this is the R equivalent, what would be the current which would be flowing through the circuit in this part? We know that V equals to I into R. So V equals to I into R. Now the potential drop across 5 is given as to be 1.226. So we can say that 1.226 equals to I into resistance is 5 into 10 raised to the power 3. So I value would turn out to be, current would be 1.226 divided by 5 into 10 raised to the power 3. Now we can see in this situation, so this the potential drop that would exist across the capacitor would be the same potential drop that would exist across this combined 5 kilo ohm and 10 kilo ohm. Okay, or we can just redraw the circuit to be the equivalent circuit. We can just, if we draw the equivalent circuit like this, so this is our capacitor. Now if we just replace the two resistances by the equivalent resistance of 15 kilo ohm, so we can say that whatever is the potential drop across our capacitor, okay, potential drop across our capacitor would be the potential drop across this 15 kilo ohm. So we can say that VC value would be equals to I into R equivalent. And what is the value of I? It is 1.226 divided by 5 into 10 raised to the power 3. And if we multiply it by this 15 into 10 raised to the power 3, we get the potential which is existing across the capacitor. It would be 3.678. Now in this situation our capacitor would be discharging, so we can use directly the equation of the discharging. We say that V would be equals to V0 e to the power minus t divided by RC. So in this situation, what is the this potential? This is in volts across our capacitor. It is equals to 3.678. This would be equals to, what is the value of V0? The initial it was charged up to 10 volts. This is the this initial voltage, e to the power minus t divided by, what is the value of R? R in this case is 50 kilo ohms, so we say that 50 into 10 raised to the power 3 into capacitance value is 22 into 10 raised to the power minus 6. Okay, so this would turn out to be 3.678. This would be equals to 10 e to the power minus t divided by 0.33. Okay, and if we just reverse this, if we send it to the other side, and if we move into the numerator, so it would be t e to the power t divided by 0.33. It would be equals to 10 divided by 3.678. So it would be equals to 2.72. Now if we, so taking log on both the side, okay, if we take the log on both the side, then we will be getting the value of t. So finally the t value would turn out to be 330 millisecond. So which is the correct option? 330 millisecond. That means our correct option would be the A option. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.